Hi there, Mr. A here again with another problem that I decided to do a video on. Again, the question's been taken from the Wisent website, and um, it is about projectile motion. So, as usual, I will start by reading the question and then do a little bit of explanation and then launch into the question itself. Okay, so it's about a pitcher who throws a softball from a height of 2.2 meters with a velocity of 13 meters per second. How long before the ball hits the ground? How far will the ball travel? So there are two questions in there. It's first wanting to know the time of flight, and the second question is about range. Those are the terms that we use when we are describing projectile motion. Uh, so a quick word about the nature of projectile motion. The most significant thing about projectile motion that you want to keep in mind is that as soon as the object is in flight, as soon as it has been projected, in other words, nobody's holding it, nobody is connected to it, nothing is connected to it, it is just flying through air. There is only one significant force acting on it. There is a force of air resistance also, but that is very insignificant under the circumstances. The real significant force is the force of gravity. And so the motion is basically under a single force which is acting vertically downwards. So any acceleration that occurs is only due to gravitational force, and there is no acceleration in the horizontal direction. Even though if you look at a projectile, it looks like it's describing a parabola, but that does not mean that it's accelerating horizontally as well as vertically. The only acceleration is vertical, irrespective of whether it starts off upwards or at an angle or horizontally. In all situations, the only force acting on the projectile is vertically downwards, and that is the gravitational force. Okay, having said that, let us start on this question. One issue with this question is that it does not actually specify what direction the ball is being thrown. And I understand that pitchers usually don't project the ball vertically upwards, and that's understandable. However, they don't always project it horizontally either. They are usually projected at some angle between the vertical and the horizontal. And without knowing the exact grade level at which this question has been posed, I have to assume that they want us to take the direction of flight to be horizontal, at least at the moment of projection. And then, of course, under gravity, it will move however it moves. Okay, so that assumption we have to make that it is projected horizontally. Given that, we know a few things. First of all, because it is being projected horizontally, as soon as it leaves the pitcher's hand and it starts to fall under gravity, it will start falling from rest. Of course, it's not at rest, it's moving. However, you have to think of its motion in two dimensions. There is a horizontal part of the motion and there is a vertical part of the motion. The horizontal part of the motion has an initial velocity that has been imparted by the thrower or the pitcher. But the vertical component does not have a velocity. The thrower is not throwing it downwards. That is why it is important to mention whether the projection is horizontal or at some angle. And that is why we had to make that assumption because initial velocity has to be zero for us to be able to calculate whatever we're trying to calculate. Okay, so uh, if the initial velocity is zero, and we are looking for the time for which the object stays in air, then essentially the calculation becomes quite simple. All we're trying to do is find out how long it takes for the ball to fall 2.2 meters under gravity. And during the time that it falls, it's not falling vertically downwards as such. It is also moving horizontally, and that is why it describes a parabolic path. But to be able to calculate the time of flight, once it reaches the ground no matter how it falls, the time taken will be the same. It cannot, for example, uh, be going vertically downwards for 2 seconds, but then horizontally it keeps traveling for 3 seconds. That won't make sense because it reaches the ground at one instant. Its horizontal and vertical motion both are embedded into one motion. All right, so the distance traveled has to be 2.2 meters because it falls 2.2 meters as since it started at 2.2 meters height. So using the equation d is equal to VIT plus half GT squared, um, we have d equal to 2.2. V is 0, therefore V times t is equal to 0. And then the rest of that component is 9.8 times t squared over 2. Now, t squared is t squared because we don't know what t is. That is what we want to try and calculate. So why are we choosing this specific equation? Why not some of the other equations of motion? Well, the problem is that we only have initial velocity. We do not have the final velocity. And without final velocity, some of the equations of rectilinear motion or kinematic equations, as they are also known, uh, are not useful for us because then it leaves us with a component that we don't have the value for. So obviously, for an equation, for us to be able to solve an equation, uh, we need to have a single variable. And that is why this is the equation, the only equation that we can use in this situation. All right, so once we have that information plugged in, all we do is solve, and we get a value of t equal to 0.67 seconds. Now I'm going to let you work this out, do the math, use the calculator, and then if you have any issues, you can always get in touch with me at this email address. Okay. So here is the first part. What we did was we solved for t. We had d, which was 2.2. We had vi, which was 0. And we had g, which was 9.81. And since all of the units are in SI units, we can simply solve with the numbers. And then finally, when we come up with the answer, we know that the answer will also be in SI units and therefore seconds. Okay, so that is one part of it, the first part of it. We found out how much time it'll take for the ball to travel or be in flight if it's describing a projectile starting at a height of 2.2 meters and going horizontal. Now, for the next part, when we have to determine the distance traveled, which, like I said before, in the projectile terminology, that horizontal distance is called range, R-A-N-G-E, range. And that range is horizontal. The distance that we have been dealing with so far is vertical. So now we are talking about a horizontal distance which we do not know. Keep in mind, these are different directions. So 2.2 is not the distance traveled. That is just the height that it falls through. The distance traveled that the question is asking about is horizontal, starting from the pitcher and going all the way horizontally till such time as the ball hits the ground. Okay, so what do we know about that part of the motion? What we know is that the velocity is constant. Remember, there is no acceleration along the horizontal direction. And when there is no acceleration, there is no change in velocity. In other words, the velocity is constant. So once the velocity is constant, then we cannot use the kinematic equations or the equations of uniformly accelerated motion because there is no acceleration. When we try to plug in a value of acceleration and it is zero, it kind of disrupts the general the solution of the equation. Sometimes it works, sometimes it doesn't. So ideally, we don't want to use it at all. So in this situation, we use the basic equation of motion that you've learned, that velocity equals distance over time. It's also used for average velocity, but it's one of the first equations you must have learned, connecting velocity, distance, and time. And so the velocity here is given as 13 meters per second. Distance we don't know, but we found out that the time is 0.67 seconds. So all you do is plug them in. And then once you rearrange, you have t equals v times t. V is 13 meters per second. T is 0.67 seconds. Multiplying gives you 8.7 meters. And that gives you the range of the projectile. Uh, so that is basically all there is to it. Even though projectile is a unique type of motion, as long as you understand the premise upon which it is structured, that there is only one significant force, which is the force of gravity, then the rest of the situation falls into place. You must always try and work out different parts of the projectile motion in terms of its horizontal motion or vertical motion. So keep those two things separate and you should be okay with projectile motion. And as I've always said, if there are any questions, any concerns, any comments, please make sure you send me an email. Let me know how you think about it or if you've learned anything from it. And that's basically all there is to it. So here is Mr. A signing off. Thank you very much.